Following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. All right, so today we're going to wrap up this chapter looking at section 7.7. Tonight, your homework will be to complete 7.7 as well as chapter review material. And then tomorrow we will review. And then on Wednesday, we'll have the chapter 7 test. All of you should have received in your email a PDF file of the chapter 8 material. If you did not receive that and you want it, please email me and let me know. Anyway, so we're going to go ahead and get started. Unless there's any questions. Do you have any questions from 7.6? Nope. Okay. Then we'll get started here. And all right. So we're going to take a look at section 7.7. And I'm going to start out by drawing some tables. So give me a minute here. Let's see here. We've got this, and then okay, and let's see here. All right, this says snowmobile and 4x4 truck. This says R times T equals D. This is an R and a 4 and a 3 and an R minus 5. Okay, so what we're going to look at here in this table has to do with the following formula. Distance equals rate times time. So if you know the rate at which you're traveling, say 40 miles an hour, and you know the time, say 1 hour, you could calculate the distance you'd travel. The rate of 40 miles an hour times the time of 1 hour, you'd travel 40 miles, right? Okay, but let's take this formula and let's solve it for t, okay? So to solve it for t, what would we do? We would divide both sides by r. So then we would have d divided by r equals t, right? So t equals d divided by r. So we could fill in the missing values in the table using this. If time is distance divided by rate, then time would be 4 divided by r, that is distance divided by rate. And in the bottom, it would be 3 divided by r minus 5. So we could fill in that variable in terms of the other variables in the formula. Any questions about that? Okay, let's take a look at another example similar to that. For this, we have another table. Let's see. That's all we need there. That and that. And this. Okay. So this says city savings bank. And this says credit union. And we have P times R times T equals, let's move that over a little bit, times T equals I. And we have, let's see, an R here, an R minus 0.02 there, a 1 there, and a 1 there, and a 50 there, and a 75 there. Okay, so this table has to do with the simple interest formula, I equals PRT. Interest equals principal times rate times time. Now, in this table, we're going to fill in the empty spaces below the P, or the principal. If we take this formula, I equals PRT, and we divide both sides by RT, we get P equals I over RT. So that would mean this first box under the P would be 50 divided by RT. T is 1, R times 1 is R, so this would be 50 over R. Then the second box below P would be 75 over R minus 0.02 times 1, or just R minus 0.02. So again, we're writing one of the variables in the formula in terms of everything else in the formula. Any questions about that idea? We'll be doing that later on. Okay, let's do a little review of some converting between percents and decimals and percents. So write 9% as a decimal number. So 9% would be 0.09. You move the percent or the decimal point 2 places to the left, drop the percent sign. So 9% is 0.09. Are you okay with that? All right, let's go the other way. Write 0.035 as a percent. So here we would move the decimal point 2 places to the right and add a percent sign. So kind of the opposite of what we did up here. Again, any questions about that? All right. So here comes another problem. It says, if a number is added to the numerator of 5/7 and twice as much is subtracted from the denominator, the result is 8. Find the number. All right, how about if we let the number be x, okay? If a number is added to the numerator of 5/7, so we have 5/7, we're going to add a number to the numerator. And twice as much is subtracted from the denominator. So we've got 5 plus x divided by 7 minus 2x. Again, let me read through that. If a number is added to the numerator of 5/7 and twice as much is subtracted from the denominator, the result is 8. Find the number. Okay? So now we have a rational equation. We have an algebraic equation that contains at least one fraction. I'm going to clear the denominators by multiplying both sides of this equation by the least common denominator, which is 7 minus 2x. On the left side of the equation, the 7 minus 2x is reduced down to 1 over 1, and I'm left with 5 plus x. On the right side of the equation, distributing, I get 8 times 7 is 56, 8 times minus 2x is minus 16x. I'm going to put all the x's on the left side of the equation. So I'm going to add 16x to both sides of the equation. I get 17x plus 5 equals 56. Then I will subtract 5 from both sides of the equation. 17x equals 51. Dividing both sides by 17, x equals 3. Find the number 3. Let's check our work. So the original equation, but putting 3 in for x, we'd have 5 plus 3 over 7 minus 2 times 3 equals 8, which is 8 over 7 minus 6. 8 over 1 equals 8. 8 equals 8. So the number is 3. Any questions about that example? All right. Let's take a look at another example then. This says, fast cars. The top speed of a Dodge Charger SRT 8 is 33 miles per hour less than the top speed of a Chevy Corvette Z06. At their top speeds, the Corvette can travel 6 miles in the same time that a Charger can travel 5 miles. Find the top speed of each car. So what have we got here? We've got speed or rate. We've got distance. And we've got time. All right. In a previous example, we explored the formula that distance equals rate times time. So because this problem involves rate or speed, distance, and time, we're going to use the formula D equals RT. Okay. So let's see here. Let's do this. I'm going to erase this now that we know we're talking about distance equals rate times time. And let's make a chart. Okay. Let's see. Distance equals rate times time. Now, the author puts these in the other direction, distance times rate times time equals distance, but I prefer to do it this way. What do we have? We have the Dodge Charger, so let's call it the Dodge. And we have the Chevy Corvette, so we'll call that the Chevy. Okay, now, let me read through it again. The top speed of a Dodge Charger SRT8 is 33 miles per hour less than the top speed of a Chevy Corvette. So if we call the Chevy's speed R, the Dodge would be R minus 33 miles per hour. Okay? Any questions about where I got that? At their top speeds, a Corvette can travel 6 miles. So the Chevy, 6 miles in the same time that the Charger, the Dodge Charger, can travel 5 miles. So we know the distances, we know their related rates. Do we know anything about the time? Yes, we do. It says, at their top speeds, a Corvette can travel 6 miles in the same time that a Charger can travel 5 miles. So we know that the times for the Dodge and the time for the Dodge and the time for the Chevy are equal. I'm going to just put a little sort of a sideways equal sign there for now. Okay. Now, if distance equals rate times time, I need to isolate time because that's the empty boxes in the chart. So I'm going to divide both sides by the rate. So time equals distance divided by rate. So for the Dodge, the time would be 5 divided by R minus 33. The time for the Chevy would be 6 divided by R. But we know the times are equal. So that means that 5 divided by R minus 33 equals 6 divided by R. There is our equation. Any questions how I got that before we go on? Okay, so I now have a rational equation. I'm going to solve it for R. I'm going to multiply both sides by the LCD, which would be R times R minus 33, R times R minus 33. Okay, so I'm multiplying both sides of the rational equation by the least common denominator. On the left side, the R minus 33s reduce out down to 1 over 1, and I'm left with 5R. On the right side, the R on top and the R on the bottom reduce down to 1 over 1, and I'm left with 6 times the quantity R minus 33. Going on, I get 5R equals 6R minus 198, 33 times 6. I'm going to subtract 6R from both sides of the equation. Negative R equals negative 198. Divide both sides by negative 1, R equals 198. And that's 198 miles per hour. So back to the original problem, it said find the top speed of each car. Well, the Chevy was R, so that would be 198 miles per hour. And the Dodge was R minus 33. So if we subtract 33, we get what, 165 miles per hour. So there's our answers. So we set up a table using the formula distance equals rate times time. Took the fact that the times were the same for both vehicles, wrote each formula in terms of time to create our new equation. Solved it by multiplying both sides by the LCD and going on from there. Any questions before we proceed to the next example? Okay. Coming up next, this says boating. A boat that travels 18 miles per hour in still water can travel 22 miles per hour downstream in the same time as it takes to travel 14 miles upstream. Find the speed of the current in the river. Okay, so what we've got here is a boat is traveling upstream, which would be against the current, downstream, which would be with the current. Think about an escalator. We have, I think the only place I know of in Yakima, which assuming that's where you are, there's an escalator in the Valley Mall, though currently I don't think it's running. But so an escalator, there's an up escalator that takes people up, and a down escalator obviously takes people down. Well, if you get on the escalator and you just stand there, you move the speed of the escalator. But let's say that you're in a hurry, and so when you get on the escalator, not only do you get on it, but you continue to walk up the escalator. So you're traveling at the speed that you're walking plus the speed of the escalator, okay? Now, what if you decide to go down the up escalator? That's like going against the current or against the wind, okay? Let's say that the escalator is moving at 2 miles per hour. In fact, let's back up a minute. Let's go back to the first scenario. The escalator is moving 2 miles an hour. You get on it and you're walking in the same direction it's moving, and you're walking at 3 miles an hour. How fast are you actually traveling? 2 miles an hour for the escalator plus 3 miles an hour walking, you're traveling 5 miles an hour, okay? But now you're going against the direction of the escalator. So let's say you're going down the up escalator. It's coming at you at 2 miles an hour, and you're walking down it at 3 miles an hour. Okay, so now what you would do, you would take your, or what would you do? You take your 3 miles an hour minus the 2 miles an hour of the escalator, and you'd actually only be moving 1 mile an hour. Now, if I've got you completely confused, let's go back and think about this way. If you're going with the escalator speed is added to your speed. If you're going against the escalator speed is subtracted from your speed, okay? Let's take this scenario to do with the boat. It says a boat traveling 18 miles an hour in still water can travel 22 miles downstream in the same time it takes to travel 14 miles upstream. So it says the speed of the boat in still water, that's without any current. So if it can travel 18 miles an hour by itself, then traveling downstream, you'd have 18 miles an hour plus the speed of the current. Traveling upstream, you'd have 18 miles an hour minus the speed of the current. Does that make sense? Okay, so let's see what we're dealing here with here. We're dealing with miles per hour, that's a rate. 22 miles, that's a distance. The same time, that's time. So again, we're talking about distance equals rate times time. So we'll make a table. And let's see here. We have, downstream and upstream. We've got distance and rate and time. Distance equals rate times time. Okay. A boat is traveling 18 miles per hour in still water. So we'll say the boat equals 18 miles per hour in still water. That's what it's capable of on its own without the current helping or hurting it. Okay. It can travel 22 miles downstream in the same time it takes to travel 14 miles upstream. Okay, so downstream, the distance is 22 miles. Upstream, the distance is 14 miles. It said in the same time. So once again, our times are equal. Now, how about if we let R equal rate or speed of the current, okay? Current of the water. That's what we're trying to find. Find the speed of the current in the river, okay? So traveling downstream, the boat's going 18 miles an hour plus the current. Traveling upstream, the boat is going 18 miles an hour minus the current. So going downstream with the current, the speed of the current is added to it. Going against it, it's subtracted from it. What does it mean to go with the flow? Take the easy way, right? You hop in the stream and you let the stream carry you. So going with the flow, going with the current, it's helping you. Okay. There's a song by a guy named Bob Seger. It's been around a long time. And I think it's called Against the Wind. And he's talking about running against the wind. Okay. What does that mean, running against the wind? Well, the wind is against him. It's holding him back. It's hurting his progression. Okay. So running against the wind would be like if you're paddling upstream against the current's hurting you. If you're going with the flow downstream, it's helping you. Okay. So careful you don't get those mixed up. Now, distance equals rate times time. And we divide both sides by rate. Time equals distance divided by rate. So the time for downstream would be 22 over 18 plus R. The time for upstream would be 14 over 18 minus R. But the times are equal. So once again, here's our equation. 22 over 18 plus R equals 14 over 18 minus R. Solving this equation, we'll multiply both sides by the LCD, which is 18 plus R times 18 minus R. 18 plus R times 18 minus R. On the left side, the 18 plus R is reduced to 1 over 1. And we're left with 22 times 18 minus R. On the right side, the 18 minus R is reduced to 1 over 1. And we're left with 14 times the quantity 18 plus R. Any questions about that step? Okay, so going on, we'll distribute 18, let's see, 22 times 18. It's Monday, I'm going to be lazy and use my calculator. 22 times 18 is 396 minus 22R equals 14 times 18, 252 plus 14R. I'm going to solve for R on the left side of the equation. So I'll subtract 14R from both sides. I get what? 396 minus 36R equals 252. Then I'm going to subtract 396 from both sides of the equation. I get negative 36R equals, let's see, if we have 252 minus 396, we get negative 144. Okay. If we come in and divide both sides by negative 36, R equals 4. Okay. Now, it said find the speed of the current of the river, which was R. So speed of current equals 4 miles per hour. We okay with that? All right. Let's see here. New scenario, new example. This one says, comparing investments. An amount of money invested for 1 year in a savings account will earn $1,500. That same amount of money invested in a mini mall development will earn $6,500 interest in a year because the interest paid is 10% more than paid by the savings account. Find the rate of interest paid by each investment. All right, so what do we have? We have money invested, that's principal. 1 year, that's time. We'll earn $200, $300 interest. And the interest paid is 2% less than paid by the bonds. So that's the rate. So basically we've got what is it? I equals PRT. Interest equals principal times rate times time. So that's the formula we're going to use. Here comes a table. It's a little bit longer. See what happens when I don't use the ruler. Okay. I equals P times R times T. And what were our two investments? Let's see. One is a savings account. The other is a mini mall. Yeah. Mini mall. Okay. So an amount of money invested for 1 year in a savings account, so that time is 1 year, will earn $1,500. That's the interest. Okay. That same amount of money invested in a mini mall development will earn $6,500 interest in a year. Okay. Because the interest paid is 10% more than that paid by the savings account. So how about if we let R equal the rate of pay or the rate of interest paid? So the savings account is R, the mini mall is R plus 10% or 0.10, converting 10% into a decimal. Okay. So we've got everything except the principal, but reading it again, an amount of money invested for 1 year in a savings account will earn $1,500. That same amount of money invested in a mini mall development will earn $6,500 interest in a year. So the principals are equal. Okay. Well, if I equals PRT, dividing both sides by RT, we get P equals I divided by RT. So the principal in the first box is going to be $1,500 divided by 1 times R, or R. The principal in the second box is going to be $6,500 divided by R plus 0.10 times 1, which is R plus 0.10. Just like in the previous two examples, two things equal, that creates our equation. So the principal of the savings account equals the principal of the mini mall. So our equation becomes 1,500 divided by R equals 6,500 divided by R plus 0.10. Any questions yet? Question?
Yeah, maybe I missed it. Where did you get the 0.10 from?
Okay, all right. So it said That same amount of money invested in a mini mall development will earn $6,500 interest in a year because the interest paid is 10% more than that paid by the savings account.
Gotcha. Sorry, I missed that part.
That's okay. So 10% becomes that. So I
Right.
converted it. Yeah. Okay. Not a problem. All right. So now our LCD is going to be R times R plus 0.10. R times R plus 0.10. Okay. On the left side of the equation, the R's reduced down to 1/1, and we're left with 1,500 times R plus 0.10. On the right side of the equation, the R plus 0.10 reduced down to 1/1, and we're left with 6,500 times R. So now that we've cleared the fractions, on the left side distributing, we get 1,500 R plus 1,500 times 0.10 would be 150. I'm going to solve for R on the right side of the equation. So I will subtract 1,500 R from both sides of the equation, and I get 150 equals 5,000 R. Divide both sides of the equation by 5,000. So R equals 150 divided by 5,000. And let's go to the calculator and see what we get. 150 divided by 5,000. I get 0.03. But that's as a decimal. What would that be as a percent? It would be 3%. Okay. Now, it says, find the rate of interest paid by each investment. So the savings account would be R, which is 3%. The mini mall would be 3% plus 10%, so that would be 13%. Okay with that? So here's the answers to that one. All righty, so for tonight, you've got section 7.7 as well as the chapter review material. Tomorrow we'll review for the test on Wednesday as before, and I'll mention this again tomorrow. There won't be any regular class on Wednesday, the test day. I will also be back this afternoon at 1:15 with an office hour, should you have need of me. Anyway, have a great rest of the day, Russ. And with that, I'm going to stop the recording.